Good viewers, once again, you're welcome to our teaching series. Today, let's take a look at a very simple problem in electromagnetism. Now, here we have that an electron in a particle moves with an acceleration a. We don't know the acceleration with which it moves. If the speed with which the electron moves is 5 times 10 raised to the power 6 meters per second, it encounters a magnetic field of 0.4 teslas at an angle of 30 degrees. We should calculate, number one, the magnitude of the force, and number two, the acceleration of the electron. How do we solve this problem? Quickly, let's go together to solve this problem. First thing we do here, let's get the parameters from the question. And the parameters given in the question, they are: number one, we have the speed of the electron. So the speed of the electron is given to us as 5 times 10 raised to the power 6 meters per second. 2, we have the magnetic field strength. The magnetic field strength, B, is given to us as 0.4 teslas. We also have here the angle. The angle theta is given to us as 30 degrees. And we know that that the mass of the electron is approximately 9.11 times 10 raised to the power minus 31 kilogram, and the charge on the electron is 1.602 times 10 raised to the power minus 19 coulombs. Now, having gotten all the details needed to solve the problem, we are going to apply what we call the Lorentz force equation. And the Lorentz force equation says that F is equal to QVB and sine theta. From this expression we have here, where F connotes the force and Q here is the charge on the electron, the velocity with which it moves, and here we have the magnetic field strength. Now, substituting this into our equation here, we have that the force on the electron will be equal to the charge of the electron, which is 1.602, and times 10 raised to the power minus 19, times, what do we have? The velocity with which it moves, 5 times 10 raised to the power 6 meters per second, times the magnetic field strength given to us as 0.4 teslas, times the angle sine of 30 degrees. Now, let's take this. So this is equal to 1.602 times 5 times 0.4 and times 10 raised to the power. Now we have 10 raised to the power 19, 10 raised to the power 6, and 10 raised to the power minus 19 times 10 raised to the power 6. Now the bases are the same. We add up their powers. So minus 19 plus 6. Then times, here we have our sine 30 degrees. So this is going to give us 1.02 times 1.602 times 5 there times 0.4. That is giving us here 3.204. 3.204 times 10 raised to the power minus 19 plus 6 is going to give us minus 13 times sine 30 degrees. So what do we have there? Sine 30 degree here. Sine 30 is equal to 0.5. So we have the force as equal to 0.5, which is the sine 30 degrees, times 3.204 times 10 raised to the power minus 13. Multiplying them together, 0.5 times 3.20. So that will give us the force now will be equal to 1.602 times 10 raised to the power minus 13 Newton. Now this is the force on the electron. The force on the electron. Now number 2, we have to calculate the acceleration of the electron. Number 2, acceleration of the electron. Remember, we have that force is equal to mass times acceleration. And we already have the mass of the electron here as 9.11 times 10 raised to power minus 30. So the force, we have the force here as 1.602 times 10 raised to power minus 13 will be equal to the mass of the electron, which is 9.11 times 10 raised to power minus 31 times the acceleration. So the acceleration A will be equal to 1.602 times 10 raised to power minus 13 divided by 9.11 times 10 raised to power minus 31. So from what we have there now, so the acceleration A now will be equal to 1.602 divided by 9.11, then times 10 raised to power minus 13. Now this is minus 31, it comes to become plus 31. So that will give us, what we have there is 1.602 divided by 9.11. That is giving us, so we have the acceleration A as equal to 0.175 times 10 raised to power. Here we have minus 13 plus 31. So minus 13 plus 31, that is going to give us 18 times 10 raised to power 18. So acceleration will be equal to 1.75 times 10 raised to the power of 17 meters per second. So that is the acceleration of the electron. Now, take advantage of what you have. You can make more research with your textbook. Go to Electromagnetism. You see so many questions that pertain to this. In our next episode, we'll do more on this. Thank you. Bye.